have this problem MinStack, and you can read the description of this problem. I would say it's a pretty good problem. You know the solution, only then you can write it down, otherwise it can be difficult. Although the problem states that you just need to write these functions such that all of them are in constant time. If you think of writing a normal stack, you can define a stack here of type int, and you can in push you can write stack.push value, in pop you can write stack.pop, in top you can write stack.top. But the problem with come in writing this function getMin, because what you need to do is you need to traverse your entire stack and find out what is the minimum of all of them. However, if you do that, your time complexity will be big of n. Not to mention that you need to create a dummy data structure, which would also have, you would need to pop one element and store it in that dummy data structure so that you can you can again copy paste from the dummy to stack again. So it would be big O of n and big O of n again for copying pasting one time and copying pasting another time, and also the space complexity will be big O of n. So this does not fit our criteria. So what can we do? What sort of things you can think of here? Well, I have one solution. Let's say that let's take one example because that would be better. Okay, let's look at this example itself. So the initialization would just do nothing. It initializes the whole thing. Push -2, push 0. Okay, at this point, push of -2, you know that if I do push of -2 and then let's say I ask getMin, then I know that it's only one element in my stack for now, so that has to be the minimum. Okay, so -2 will be the answer. Now let's say I do push 0 again and I ask you again what is the minimum. Then what do? You don't have a track of that. So you need to keep track of your minimum element which you already have seen before. And then you can compare it with the new value which is being asked to push. So you will compare. So you need some sort of a data structure or some sort of variable which would keep track of the minimum number up till now. And then at the present value, you will compare it with the present value. If it is less than the minimum number in the stack, then you update it. If not, then you don't do anything. However, there is a way to do it. You can't have a global variable and then check it again and again, because what if, let's say that in this example you also pushed -3 and you have written your global variable, minimum global variable is -3 because you updated it. Then let's say we get a pop sometime in future. Pop will pop this element which is -3, but your global variable will still hold the value of -3 as the minimum, which would be incorrect. So you need to also keep track of the element you are popping. So does that ring a bell of what can we do? So we need to store the minimum value in our stack itself along with the number, because if we pop an element and that happens to the minimum value as well, then we will pop that entire element with the element and the minimum itself, so that whatever is the topmost value after the popping, whose minimum we already know because it's a part of our stack. If that did not help, let me write it down and it will have a better understanding. So what I'm saying, I'll have a stack of pair integer where the first value will be the value itself and the second value will be the minimum up till that moment. Okay, what will we do if we encounter push? If we encounter push, we'll say we'll push our value first and then we will push the minimum of our value and stack dot top dot second. Why stack dot top dot second? Because our second value, which is this value is holding the minimum number. So we are comparing with the previous minimum towards the current value. Whatever is the minimum of these two, we are storing it in our stack as the minimum value. Now there is one little problem here because our stack is empty for now. So this value would result in a runtime error. So we also need to enter something like if our stack is empty, then what do we do? If there is only one value, then we know that that value itself is the minimum. Okay, and if that's not the case, then we do this. Does that make sense? I hope it does. Now for popping, what we can do, it's simple. We just do stack.pop. That's it. For top, what can we do? We do stack.top dot first because this is what is there at the current top. And what is our getMin? It's simple now. It's at the top and then dot second. Let's run and see if this works or not. Okay, it gives someone, oh, we need to return it because it's an integer type, and this also. Need to wait some time. But you guys did understand what I just said, right? Why am I keeping a track of the minimum element? Because I want it with my stack, because I don't want to lose it. If I keep a global variable, then it will have its own problems because I have to check if this is the element I popped, then again I need to update. There is no way of knowing it. Alright, so it does run fine. Sample test case is passed. Now let's, for what is the time complexity and space complexity of it? The time complexity is constant because we are not traversing anywhere or doing any kind of all these operations are constant. And space complexity, you can say that this stack will hold some space because at one by one elements are pushing. So you can say at maximum it will be the number of operations included in this input. So these operations, imagine all of them would be push, then a stack size would be the number of input. And they have given this additional constraint. They have always mentioned that these things will always be called when the stack is non-empty. That is why we are not writing any condition here. Okay, let's try submitting it. And it's accepted.